So this is my assignment for geometric shader, and the code is based on the previous one, the silhouette detection one. So I used the same procedure to detect and generate silhouette edges. Uh, just like last time, we have two objects in this world, one cube, one spaceship, and I can switch the projection source from camera view, from camera to uh, another source that is represented by a sphere, and I can switch on and off about of the silhouette detection. And yeah, there's a slider to adjust the distance of how far the silhouette will be stretched uh, along the projection direction. So a smaller distance will have a better visual clue of if the shadow volume is correct, and the larger distance is more useful when performing actual shadow detection, because it has better chance to intersect with other objects in the world. So if we move the object to rotate, we can see how the shadow volume uh, changes accordingly. And also we can make the sphere to orbit around the object. And of course, like last time, we can attach the camera to the sphere, but there's nothing to be rendered because the silhouette edges are stretched along the direction of the side, so we cannot see anything. And once we stop, then we can see this silhouette. We can see this shadow volume again. And one thing to be noticed is that the surface of the object that is covered by the shadow volume are not rendered. Even though I switch on the blending mode and also I set the alpha channel of the shadow volume to be some value that is smaller than 1, but still it covers the surface of the object. Now, I'm not sure if it has something to do with the Fitzcarraldo thing or not. Yeah, we can do the same thing for the space shape. The major changes in code is that I add a new shader class, and that is inherited from the GLSL shader per vertex color, and the only two functions that I override are the new function and the constructor. So in the new function, I basically follow everything the default shader does. Load the shader programs and compile them and call the constructor. And in the constructor, I reuse everything that is already there in the per vertex color shader, but I add new two uniforms. One is called projection source. That is the uniform to hold the position of the projection source. And another uniform is called shadow distance. That is the value controlled by the slider. And the only difference in the uh, silhouette detection procedure is that I set the new shader to be the shader of the silhouette object, which is MGL primitive shape object. And also when I draw the silhouettes, I set the values of those two uniforms the first one to be the XYZ position of the current projection source, and the other one, the shadow distance, is the value that is controlled by this slider. And for the shader programs, I just copy and paste whatever it is from the previous one, from the existing one, default vertex shader and per vertex color fragment shader, and I made a new geometry shader. So in this shader, it indicates the input primitives are lines and the output are triangle strips. Since we are stretching the silhouettes lines to be to quads, so the maximum vertices are 4. And also projection source to hold the position of the projection source and the shadow distance. So first, from the vertex shader, we can get the positions in clipping space of the endpoint of the silhouette, and then use the model matrix to convert the position space to convert the position of the projection source back to the model space, and then use the MAP matrix to convert the coordinates of endpoints back to their model space, to their local space. Sorry, and then by subtracting the endpoint and the projection source, we have the two directions along which the silhouette ends will be stretched. Here we emit the original endpoints, and then for the two new endpoints, we add them. We use their coordinates in the local space plus the direction times some distance to get the position of the new vertex in the local space, and then use MAP matrix to transform them into a clipping space, and then emit the new vertices.